All right, so we are looking at this problem from Mastery 4, and this is the problem where we want to see the transformations. So in order to do this type of problem, we want to refer back to our discussion on transformations and the vertical translation, the horizontal translation, and the reflection and the vertical stretch, compression, horizontal compression or stretch. So let's refer back to when we talked about this, we created ourselves a table, and the table would show you what would happen to your X and Y points, right? You had ordered pairs. So I'm going to put that table on the screen so we can refer to it. So here are our transformation rules. We talked about these in class. And so we are going to now take a look at, we want to pay attention to this column. So we'll start by taking a look at this, and here, let me write on here. I am going to be going, it says we've got P of T is graphed below, so this blue line here. And then we have the points, the one in red, the one in red is a 4, 0. And that gets transformed to -2, 1. And the one in blue, that is -3, -5, gets transformed. And now in this graph of f of t, that point has moved to 1.5, -9. So I want to see if I can see a pattern of what's happening. So in this one, in the y point, it starts at 0. Now, 0 is hard to, like, when you multiply by 0, it doesn't change anything. So there actually could be some compression or stretching going on, but when you multiply by 0, we're not seeing that in this point. But I do see that to go from 0 to 1, I'm adding 1. And I know in the y coordinates, when I look at the y coordinates and I look at this, the one where you're adding 1 is this first one here. So a vertical shift up k units. Now let's take a look at the next point and see if there's the same thing. Do I see I add 1 here? And the answer is no. I don't just add 1. There's something else happening. So now we can try to figure out what is happening by setting it up like this. We can say, well, I think what's happening is -5 is getting multiplied by some number. And let's call it A. And I'm calling it A because on this chart here, this was the only one that multiplies the y coordinate besides the negative, the reflection, is with the A. So, but you can call it anything. I'm just telling you why I'm calling it A. So we're doing something to the y, the -5, multiplying it by something, and then we're adding 1. And that's how we're going to get to -9. So I'm going to say -5a is equal to, subtract 1 from both sides to get -10. Divide both sides by -5, and I get an a of 2. So I think that what's happening here is we are multiplying by 2 and adding 1. So that means that if I follow my translation, that my function, which was my original function, is p of t, I would have to multiply by 2 in order to get the y coordinate to the outside, right? I'm looking at a vertical stretch, and that means the 2 goes outside. Take a look at this. Vertical stretch, the 2 goes outside. And then I add to the outside 1 for that vertical shift up 1 unit. So far I've got this, and that takes care of my y coordinate. Now take a look at the x coordinate. For the x coordinate, I see that this is dividing by -2. And what about this x coordinate? Is this divided by -2 also? Yes. So in order to divide by -2, let's look at our transformation, the x coordinate. Now look at the x coordinate. So here, let me pull this whole page over. Which one of the x coordinates divides by a number? It's this one. It's a horizontal compression. And so, but this is our B. So there's also some reflection over the y-axis. So it's a reflection over the y-axis. So there's going to be a negative B value. So in place here, I'm going to put -2. And now I'll enter that in to the web work. And in the web work, you'll notice that it will have f of t, and then you plug in this part. So it's your function. You're multiplying the input by -2, and multiplying the output by 2, and adding 1 to get that transformation. And that's how you do this type of problem that you're seeing in the math tree.